Okay, can everybody hear me? Yeah? Great. So, the topic of this talk today is scalability without complexity. And clean architecture can get very complex. Now, we just had lunch. Everybody's probably in the time where they want to go to sleep. I hope I don't make anyone sleep today. Because the whole objective of this talk is to make it very approachable, very easy to understand, right? So, okay. Yeah, so I'm Sebastian. I've been in the development industry for close to 15 years. I started very young, and I'm still in love with software engineering. If you want to follow me on GitHub or LinkedIn, here's some of my information. And a fun fact about me is that I speak fluent Belizean Creole. And probably nobody ever heard about Belize or Belizean Creole, but if you ever want to go there, it's a beautiful place. I love it, and I would go back if I could. So, invited to Belize. So, let's dive into the topic. Why clean architecture? I want to tell you why using a story. And a story takes place during the pandemic. During the pandemic, I decided that I wanted to plant tomatoes in my backyard. I wanted to plant tomatoes in my balcony, and these tomatoes, I hoped I never had to go to the marketplace. You know, everybody was wearing a mask, and you could get COVID. So I wanted tomatoes without going to the marketplace. And I planted my tomatoes. I got the earth, I got soil, I got the seed, I put it in the backyard. I put water on it, and sun hit the plants. Soon enough, some plants were growing, and they looked beautiful until one day they didn't. Until one day, all of them looked like this. They were all dead. And I wondered what happened to my plants. I thought that it was the ants that took the fruit of the plant. But you know what? When I started to look at the plants, I realized that it was going to be very hard for me to know what exactly went wrong. What happened to my plants was the question I wanted to answer. So I realized, or I related this to my experience with clean architecture. I realized that I didn't follow a proper structure. I didn't follow a procedure. I wasn't very organized about planting my tomatoes. And that's where I said, Uncle Bob was right. Chaos loves homogeneity. What is homogeneity? Homogeneity is everything looks the same. And you know when everything looks the same? When it's broken. When it's broken, everything looks the same, especially if you didn't take care into the process. So, for the purpose of this talk, chaos is a lot of sameness. Things that grow with little care. And order is differentiation. Things that grow, but we know exactly how and when they grow. So this led me in a rabbit hole of trying to know what happened to my tomato plants. And this rabbit hole taught me about hydroponics. I don't know if you ever heard about hydroponics, but hydroponics is a very structured approach to farming. And as you can see, in a hydroponic plantation, there is a lot of specialized components that help the plant develop and give the best harvest that it can, right? It is so effective that after I researched a lot, I found out about Netherlands. And Netherlands is one of the countries with the least amount of productive soil. However, 1% of its GDP depends on these hydroponic plantations. When they implemented hydroponics, they were able to quadruple the amount of exports that they do in that country, especially tomatoes. But look at what how hydroponics is similar to clean architecture. They specialized different components and they limited them with boundaries. They separated the crops from a lot of external factors, and that's how they were able to do feedback loops and see how good or how bad a certain plant with a certain combination of components was behaving. What did they achieve? They achieved insane amounts of scale. Can we learn something about hydroponics and put it into practice in clean architecture? We can. So let's go from my balcony chaos to Dutch precision. Let's look at some examples. Sorry, my mouth was dry. Let's look at this example, for example. So we have some code here. If you don't know Python, we're going to explain it, but if you do know, you already see that there is a lot of functionality in the same place. We have this function that takes care of my plants. And first, I take some HTTP request. Then, I do some SQL. I also do some business logic inside. And finally, I send an email to myself reminding me that I need to take care of my plants. Everything in the same place. Wow, that's efficient. Is some of the code that you maintain in your company, does it look like this? Is everything in the same place? Look at the dependency graph of this function. Some people would call this function the God function because it takes care of everything and everything depends on it. Is this a good practice? No. It's exactly like my balcony because when things fail, we don't know where they failed. There is a single point of failure. And then there is clean architecture. So, when you look at this graph, what do you see? And I take this from the book by Robert C. Martin called Clean Architecture. Great book if you want to learn more about clean architecture. But when you look at it, okay, this looks like rocket science. How do I separate my balcony chaos into all these things? What is an entity? What is a use case? What is a controller, presenter, gateway? What is an external system? And how do I divide my simple balcony chaos into a hydroponics? That's what we're going to learn during this talk. And I'm going to make it simple for you. The best way to achieve this is to tell yourself the story. What story? The story of the problem that you are trying to solve. When you tell yourself the story, for example, I told you the story about my balcony chaos, and we talked about plants, we talked about tomatoes, we talked about soil. You start to define something called the domain. And the domain is that story. How you tell yourself the story will determine what component of the clean architecture you're talking about. So let's tell ourselves the story and then start to separate these things into components that we can then separate into that clean architecture. Okay, so here's the problem. We want to plant tomatoes. I'm sorry, I couldn't find tomato plants in Canva. It's Canva's fault, but just imagine these are tomatoes plants. And these tomato plants, they can go in a hydroponic structure. They can either be planted on water, they can be planted on soil, and all these things are separate. Now, you know that a plant needs attention, or else it's going to look like my plants, right? So that's a task that we need to perform. We need to garden these plants. We need to take care of them. Plants also succumb to external factors, like the sun, or like water, the amount of rain, and some different types of pests that we can have on our plants. So you see, we just told ourselves a story, but this story has different components. For example, we cannot have tomatoes without plants. And a plant cannot grow without a plant bed, like soil. And we know we need to perform an action on a plant to get the tomatoes. That is gardening. Now that we've told ourselves the story and we have clear some parts of the domain, let's look at some code example of how we would go about implementing these. Okay. Whoops. Yes. So from the graph that looks like an onion, in the dead center, there is a small yellow circle called entities. In our story, a central character of our story are plants. And so we see here the domain layer. It's a plant. Now, why is it an entity? It's because it holds a core business concept. And this core business concept, of course, has some attributes that define it and some actions that are performed on itself that can live inside that same class. But in the enterprise environment, in a real code base, what would be the rule of the thumb to identify an entity? Well, first, it's a business concept. But second, if you were to take this code and copy and paste it into a Jupyter notebook, you will be able to run it without any external dependencies. And that is key to clean architecture. We take the trash and we keep it outside. But this is clean of any external dependency. And that is what tells an entity. Now let's move on to the next part of the layer, the use case and the port. So remember that we needed to perform an action in our story, right? And that's called gardening. So here we have the gardening service. The gardening service is just a choreograph, a flow of steps that perform a specific application scenario. And when you're able to do this without external dependencies, you also protect your code from the trash and you keep it outside. That's why this use case does not contain SQL, it does not contain HTTP, it does not contain any external dependency. How would you go about getting nutrients from outside into the plant? You need some kind of structure that holds the plant in place, but does not actually bind itself to the plant. Because remember, in hydroponics, we need to be able to adjust everything. We need to control the environment, and that's the same for clean architecture. That's why the port exists. And it's also part of the use case layer, because it does not actually implement any real logic. It's just a shape. Like the vase that holds the plant is just a shape to enable the plant to get nutrients later. So here we have what would be abstractly a plant bed. So we know that a plant needs something to grow on, and when we were children, we might have grown a plant on a piece of cotton. But we can also grow a plant in soil, or we can grow a plant in sand and different environments, right? And if we're talking about technology, then we could also have SQL database or any other type of technology, right? So the port is just a shape. Let's look at how external dependencies will have to comply to this shape to make them work with our story in the next layer. I feel like when the remote control at home doesn't work and moving things everywhere. Okay, we have the next slide. The next piece of that clean architecture, which are gateways, controllers, adapters. And these pieces of the software will need to adopt a shape. If you look at it closely, for example, the hydroponic bed is shaped, or it's inheriting the shape of an abstract class, the port. The port defines the shape, but the gateways translate this shape into real technologies. So they are like interpreters between people who speak two languages. Yes, they know how to interact with the inside, but they also know how to import libraries, frameworks, and the plant and the plant bit and the gardening service, they don't know anything about that. But these translators, these pieces of software, they do. And that's the whole purpose. Okay, so when you're working with clean architecture, when you find it in the wild, what are 3 rules of the thumb that will help you identify the different layers? When you're talking about entities and use cases, you will not find any external system being imported in these. You won't find any Flask, you won't find any Django, you will not find Pydantic. Maybe you could find Pydantic, but you will not find any SQL Alchemy, for example. Second rule of the thumb would be to identify adapters, gateways, and controllers. You will see that they are like translators. They are speaking 2 languages. They speak the inner ring, and they also speak the other side, the real technology. And now we never spoke about external systems because they're easy to identify. These are systems that you only interact with through libraries or through APIs. You don't directly implement them. They belong to somebody else. They belong to Microsoft. They belong to Google. They belong to whatever other company. They don't belong to you, but you interact with them, and they're just external systems. And this is a really easy way to see clean architecture in the wild. Now you might have more questions like, there is no silver bullet. This architecture cannot solve all the problems that we face when we're working with Python. That's impossible. So how would you go about reasoning what are the trade-offs of clean architecture? Let's look at them. What are some of the pros? The pros is that when you implement clean architecture, you will be domain-free. What does that mean? That your core business logic does not have side effects that affect it from external systems. And this gives you a huge opportunity to swap those external systems when you need to. When you need to evolve your system into newer technologies or into technologies that you thought you didn't need at first, but now you do, you get to swap them because clean architecture protects the most valuable part of your code from all of these side effects. Also, since the core has that property of being pure, That means that they don't have a lot of side effects. It allows you to test each component independently and freely. Makes your test a lot easier. You don't have to mock so many external dependencies. It's going to be really easy for you to test them. And one of the biggest pros of clean architecture is team velocity. Because everybody in the team will know exactly how to perform a certain surgery, they will not affect or have a lot of conflicts with their teammates. And we know that most of the time we spend working, we spend fixing conflicts. So this is also a big pro. And the last one would be that you can future-proof your application, because when LLM stops being a thing and blockchain is the next thing, then you can swap components from AI to blockchain, blockchain to AI, vector database to whatever database, NoSQL to SQL, whatever to whatever. Remember, and I like one of the points that was made earlier, is that technology is just a tool, and it will keep evolving over time. But you want to be able to adapt. And this concept makes your code easier to adapt. What are some of the cons? Some of the cons is that you will have to think a lot before you write code. A lot of people like to run into writing the code. But with clean architecture, you will have to spend a big amount of your time thinking about those interfaces and thinking about your story. You will have a lot more files and layers, and when you try to explain it to a new person, they might have the "where is the real code" syndrome. Where am I going to find it? Well, that's one of the things. There is a learning curve to clean architecture. And you also run a risk of over-engineering parts of your system. So remember, keep it simple, stupid. It doesn't always apply to clean architecture, because you can get complicated really fast. But when you're doing clean architecture, you will have to always be thinking, do I really need this? Is my project big enough to warrant the need of clean architecture? If it's a tiny project, maybe you don't need all the rings. Maybe you just need a few. And you also need to get all the other developers on board. And that's a con. Not everybody likes clean architecture, but if you believe that it's going to help your project, fight for it and get that cultural shift. Now, there is also two problems that you can face, and is, okay, I already have a legacy product. I already have some code. Is it good for me to refactor it? Or should I just toss it in the trash and build another one? When it comes to refactor, you have to think about these things. Is the business logic still valuable? What does that mean? Is it still relevant? Because your business logic might be a thing of the past. Is it still a thing of the present? If it is, then maybe it's worth detangling the whole thing. When you think about refactoring, are building new features something slow? Are you getting blocked? If that's a problem, then you might think about refactoring. Do I find a single area where all the bugs are rising from? Then it could be a good thing to refactor that area. Is my tech stack still relevant? Am I using the latest of the latest, but I just forgot to do this thing before? Then you might think about refactoring. You already have tests on this code. And why is this important? Because when you start making changes, if you don't have tests, then you might not notice when things break. If you already do, and you want to migrate to clean architecture, and all these other things are also true, then you might think about refactoring. So here is, the goal would be, can I make surgical cleanups, incremental cleanups that implement clean architecture in my code? Then it's good that I refactor. But if it's a major surgery a heart surgery, then you might think about this other thing. Okay, oops. Rewriting. If one of those things in the past was a lie for your project, then you might think about rewriting. If you already hit vertical scaling limits, I cannot increase more resources on AWS in any way possible, and I need to do a refactor that warrants microservices, then you might think about writing those microservices using clean architecture. If your legacy stack is end of life, it's no longer supported, and it's written in some Oracle from 50 years ago, then you might think about it. If it needs some really costly Microsoft licenses, then you might think about refactoring. And if your domain, if the story that you're telling yourself, it's already fiction, is not reality, then you might think about refactoring. Because rewriting that whole domain logic, that it's already tangled in a lot of other things, then could be too costly. So the question would be, how would I go about rewriting without creating impact? And I'm going to give you just, I'm scratching the tip of the iceberg here. You can try to run it in parallel and start shifting some of the functionality to your new app using a load balancer. That's just one of the strategies that you can play off. Great. So that fast, we reach the end of this talk. So when it comes to implementing clean architecture, how can you implement it without complexity? Start with the story. Make sure you can tell yourself the story of the problem that you're trying to solve. If you have been able to separate those domain components and understand them, then you can make clean architecture. Yeah, so here's also my contact information, and feel free to add me if you want to chat about clean architecture. If you want to talk about anything related with tech, you can go ahead and add me on WhatsApp, LinkedIn, or GitHub. And I think we have some time for a Q&A, right?